Hi guys, and welcome to another video. Today we're going to be looking at Euclidean geometry, proving that a line drawn parallel to one side of a triangle divides the other two sides proportionally. And this question appeared in the June 2018 paper. It reads as follows. Question 9. Use a diagram to prove the theorem states a line drawn parallel to one side of a triangle divides the other two sides proportionally. That is, prove that xk over ky equals to xl over lz. So when we are proving any theorem, the important thing for you to remember is that you must not memorize the proof. Rather, understand what is happening in the proof. Now, how do we do that? Well, firstly, you have to understand the construction. That's number one. So we have to learn the constructions for each of our theorems. And the second thing is we have to also look at the reasons that are used in the proof. Now the reasons that we are going to be using in the proof are as follows. Number one, that if two triangles have a common vertex, a common vertex is where two lines meet. It means that they are going to have the same height. Number two, if two triangles have the same base and they are drawn between the same parallel lines, then they are going to have equal areas. So we're going to be using these two facts. That's important for us to remember. So let us now look at our proof. Xk over ky equals to xl over lz. Now let's go back to the construction. Now remember that we are going to be using area of triangles in order to prove this theorem. So what we have to do is we have to now construct a perpendicular height, because remember that the area of a triangle is equal to half base times height. Our construction is going to be as follows. We're going to draw a line which is perpendicular to xk, and we're going to join it all the way to L. H, we'll call it H, and we're going to draw it perpendicular to xk. So that will be the first thing that we'll write. We'll say draw H perpendicular to xk. Similarly, on this side, we will draw a line perpendicular to xl, and we'll draw it all the way to k. So we can now call that, let's call that k. So we've got H and k. The second thing that we're going to do is we're going to join these lines here, which is kz, and we're going to join lines y. So let's write everything down. So we're going to draw H perpendicular to xk, and what else did we do? We are going to draw k perpendicular to xl. So k perpendicular to xl. And then the other thing that we're going to do is we're going to join kz and YL. So the construction is something that we have to remember. Not memorize, but remember how it is done. Because remember that these letters here can change. Now the next thing that we need to do is we need to structure our proof. So the first part of our proof will be using area of triangles. Now let me just explain that very quickly. If you look very carefully, this proof is centered around this line KL, which is a line drawn parallel to the third side of the triangle, as our question suggests. Line drawn parallel to one side of the triangle divides the other two sides proportionally. So remember now, let's go back to the proof, xk over ky. So I want to show that xk over ky. Alright, so that's one side of the proof. So let's now look at what we're going to do there. Now if you look very carefully, you'll be able to see the following. You have the following triangles: x, k, l. That's one triangle. And then the other triangle that we have is k, y, and l. as you can see, they share this common vertex, which is L. And we're going to call that height there H. So we're going to use height H. So let's write that down. So we'll say the area of XKL, area of XKL, all over the area of triangle. Now let's write this one down. KLY. The area of triangle KLY equals 2. Now area of triangle formula that we're going to use is, remember, half times base times height. X K times H all over half times base times height, and the base here will be KY. KY times, remember we constructed the heights H, and remember what I told you first, the two triangles share a common vertex, they have the same height. So therefore we used height H for both of these areas. So we'll write down that reason. Same height H. Alright. Now if you simplify, you can cancel half with half and H with H, which leaves us with XK over KY. XK all over KY. And what do you notice? XK over KY, we've got one side of our proof done. Now let's do the other side. So we're going to do the other side in a very similar fashion. XL over LZ. Now let's look at that. So XL over LZ is going to be as follows. So XL over LZ. So the areas that we're going to be looking at will be as follows. Area of triangle. So let's look at this. Now the areas that we are going to be looking at will be as follows. So I hope that I did not complicate this diagram too much, but let's look at it nevertheless. So here we've got X, L, and K. So we've also got X, L, and K here. Alright, we're going to be using that. Don't forget, once again, common vertex KL. As mentioned previously, everything is centered around this line KL. So let's write that down. Then the other part would be, where is it here? L. So we've got L, Z, K. Okay. So let's write those two areas down. So we've got X, L, K. So we're going to say area of triangle X, L, K all over the area of triangle. And this one will be L, Z, K. So it'll be L, Z, K, which is equal to half times the base here is XL, XL times, and we call the height there K. Remember, same height, common vertex, once again. Half times the base here will be LZ, LZ times K. Once again, the reason will be same height K. So half and half cancels, K and K cancels, and now we're left with X L over LZ. What do you notice? XL over LZ. So we've got the other side of the proof, XL over LZ. Now, the next part of our proof is going to be as follows. If you look very carefully, what can you see here? Area of triangle XKL, area of triangle XLK. They are the same triangle. So therefore, we can write that down. So we'll write down the following, that the area of triangle XKL is equal to the area of triangle XLK. XLK. And those two triangles are common. Okay, so let's just put a but in front there. And the next thing that we want to write is the following. Now let's look at these two triangles, LY, this triangle here, and also this triangle here, which is KLZ. If you look at it carefully, you will see that they share the same base KL, and they are drawn between the same two parallel lines, which means that the areas of those two triangles are equal. So therefore now we will write the following. We will say that the area of triangle KLY, so we got KLY is going to equal to the area of triangle LZK, and that reason will be same base and height, and also it's drawn between the same parallel lines. Therefore the areas are equal. So once again, we've got the area of KLY equals to the area of LZK because they have the same base, same height, and drawn between the same parallel lines. Therefore, what can we conclude? Therefore, our conclusion will be that the area of triangle XKL, so we're just going to rewrite this now, XKL over the area of triangle KLY is going to equal to the area of triangle XLK all over the area of triangle LZK. Therefore, what can we conclude? We can now conclude that XK here, so we're going to rewrite this now, XK over KY is equal to XL over LZ. XL over LZ. If we go back to our theorem, what they wanted us to prove, XK over KY equals to XL over LZ. So that is now proven. Once again, when you are learning proofs, make sure to understand what is happening in the proof, learn the construction, and learn the reasons in the proof. That is, if you haven't subscribed to my channel already, JR Maths, please do subscribe, share this content with your friends and with other learners in your school. And also, you can watch all videos on jrmaths.com, like my Facebook page, Justin Lazarus Mathematics, and I'll catch you in the next video.